This is the tracing you saw, and it's sinus rhythm, and there is ventricular pacing spikes on the bottom, excuse me, one of which captures. And that's the critical part of this, one of which captures, and then you're asked to analyze the rest of the tracing. So, these are the questions that I asked you in the journal. What best describes the findings in this figure? A, concealed conduction into the AV node. B, concealed conduction into the AV node and the accessory pathway. Or C, just concealed conduction into an accessory pathway. Those are your three choices. So let's now analyze the tracing. If you take a look at the tracing, let's go beat by beat. Here is a wide complex on the surface tracing, a P wave and a wide complex. It looks like pre-excitation, but you can't be totally sure there. Then look inside the heart, and it looks like you have an early A and a V here, which is very consistent with a left free wall pathway. So these two beats go along fine. This ventricular stimulus didn't capture here, probably because the ventricle was in its refractory period. This ventricular stimulus does capture. It does not go to the atrium, so there's total VA block. But it provides us with a wonderful moment to analyze the intracardiac tracings. First, let's look on the surface tracing. So this beat is now different than these two beats. In other words, the pre-excitation is gone. So why is pre-excitation gone? Almost surely because this premature ventricular beat retrogradely conducted into the accessory pathway, preventing anterograde conduction over the pathway. So, number one, we've identified concealed conduction into an accessory pathway. Now, notice on this tracing that there is a long AH interval of 198 milliseconds. So the AH interval is long. If we go to the next beat, now we see a hiss. So we'll talk why we didn't see the hiss over here, but we clearly see a hiss present here. This AH interval is 72 milliseconds. So why is this AH interval longer than this one? Because this PVC also conducted retrograde in a concealed manner into the AV node. So this is a wonderful and fun tracing of double concealed conduction. Concealed conduction into the AV node and concealed conduction into the accessory pathway. Do know that you also have here a very close AV interval in the CS, clearly showing you that this is still conducting over the accessory pathway. So why didn't we see the hiss here? Not totally clear, except you did change some of the characteristics. Maybe this accessory pathway isn't as robust as it was. Lots of reasons you can think about, but clearly this is the hiss here. So this is a tracing of double concealed conduction.